temperature. Space has no limits, no end. Outer space is hostile, but man will go there again and again in a spaceship designed both to transport him and keep him alive. Man in outer space must breathe, work, and eat, all under unusual conditions. For example, man in space has no weight. In an airplane, it is possible to experience weightlessness for 15 to 30 seconds. He floats, he tumbles, he can even swim. Even water seems to misbehave. You can't pour liquids when there is no gravity to pull the fluid out. The slightest motion sends food or liquid floating away. Another force constantly at work is atmospheric pressure. Now, one way to blow up a balloon is to put air inside it. But the balloon also can be made to expand by removing air pressing against the outside. Here on Earth, the air around us presses against our bodies at 15 pounds per square inch. We're used to it. But in a spaceship, men and machines must function under only half that atmospheric pressure. When the Whirlpool Corporation contracted with the Aeronautical Systems Division of the U.S. Air Force to create an experimental space kitchen, scientists at the Aerospace Medical Laboratory told Whirlpool engineers, 1, the kitchen must work at 0 gravity. 2, at 1/2 normal atmosphere. 3, must be extremely light. 4, compact. 5, strong enough to withstand a takeoff strain equal to 8 times its own Earth weight. 6, must provide food for 3 men for 14 days. And 7, include a freezer, a refrigerator, an oven, hot and cold running water, and garbage disposal. To see how these requirements have been met in the Whirlpool Space Kitchen, let's take an imaginary trip into outer space. 3, 2, 1, blast off! Welcome to outer space. Are your eyes adjusted to this red light? In outer space, we get used to it. The low level helps conserve our limited electrical power. However, let's make it brighter so you can see. I'm one of 3 men on the first rocket trip around the moon and back. It's a 14-day trip, so we have to eat. We take our meals one at a time. That's why I'm now in the Whirlpool Space Kitchen. It's less than 10 feet long and fits against one side of a capsule only 7.5 feet in diameter. Fully loaded with food, it weighs only 800 pounds. It has pull-down wall cabinets, and canned and dried foods slip into individual pigeonholes in the sides. Handles help us guide ourselves when we float in to get a meal. A knee bar holds us down in the seat when we eat. You notice this overhang here down near the floor? Well, this also helps us to maintain our stability. And although this kitchen is small, it stores up to 126 complete meals, plus a few extra snacks, like cookies for the times when we get an urge to raid the refrigerator. When we blasted off, the freezer contained 108 cans of food and 189 bread items. Total weight of all the food aboard is 236 pounds. Now then, as we travel, we transfer some things from the freezer into the refrigerator, where they defrost enough to shorten cooking time. Both the freezer and refrigerator are thermoelectrically cooled. No compressors, no pumps, no motors. Just 28 volts of direct current. When you put 2 different kinds of special metal together in a certain way and pass an electric current through them, One side of this metal junction gets hot, the other cold. When you put the cold side inside an insulated box, you have a refrigerator or a freezer with no moving parts, no noise. Of course, we have to heat our food too. The warming oven has 3 holes or cavities, each big enough to hold 1 can of food. Now the water tanks are over here. This upper one is for cold water, and this one down here is for hot. By the way, that's a pretty special water heater. Back down on Earth, heating water is a fairly simple procedure. You simply apply heat to the bottom of a pan or tank, and as the hot water rises, the cold water descends, and it all gets heated evenly. But at 0 gravity, that doesn't happen. Heat doesn't rise. So the Whirlpool engineers had to figure out a way to heat all the water in the tank at the same time. And if you think these tanks aren't very big, you're right. For 3 men for 14 days, there's only 3¼ gallons of water. That's about a gallon per man, and that's all. Because we have so little water, wastewater must be recovered and purified in a special system outside the kitchen, and then reused. With this water transfer tank, we get water out of the recovery system and pump it back into the water tanks. You notice how I have to hang on while pumping? Otherwise, I'd push myself right up against the ceiling. Watch this. See what I mean? Now, in outer space, you can't throw anything out the window. You can't burn it. You can't bury it or take it to the dump. You have to live with it. Yet, you can't permit the ship to become a flying garbage can either. So, whenever we finish with a can or tube of food, we spray it with an iodophore, a kind of modified or tamed iodine, which retards the growth of bacteria. Then, we reseal the container and put it back where we got it, thus conserving storage space. Things we can't reseal, like wet and dry napkins, go into a wet storage compartment, where they too are sprayed. Dry things, like uneaten cookies, are put into a dry storage bin and kept dry by a special chemical. And you'd be surprised at our fancy menus. According to the scientists at the Aerospace Medical Laboratory at Wright-Patterson Air Force Base, men on an extended trip through space could survive on K rations, but their morale might suffer. And more important, they might not be able to work efficiently. So they deliberately made mealtime the high point of the day. We're just past the halfway mark on this trip, the 8th day, a Monday. The menu calls for apricot nectar, Swiss steak, buttered string beans, candied sweet potatoes, bread and butter, coffee or tea, and chocolate cookies. I don't like chocolate cookies, so I swap mine for some frozen strawberries. You know, those nutritionists thought of everything. They even made up these menus to encourage swapping. Well, it's about time for me to eat, so first I'll set up my tray. Each man has his own. Now, the apricot nectar. A dry powder until I clipped off the end of the tube and filled it with water. Then I hung it in the refrigerator to chill. There's a little lip on the end of the tube to help me hang onto it with my teeth. Unless I roll the far end of the tube, nothing comes out. There's a metal spring clip at the nozzle end to keep it closed until I put enough pressure on the tube to force out the liquid. This would be no place to have the air full of floating apricot nectar. Now I lock the tube to my tray until I'm ready to eat. The steak, string beans, and sweet potatoes are all in the oven, where I put them to heat about 30 minutes ago. While they're only 165 degrees, they're a little too hot to handle barehanded. We have special feeding nipples, one for each can. The nipple, made with a slit that allows pretty good-sized chunks of food to pass, is fastened to the top of the can. This handle arrangement is an expelling device. Each time I squeeze the handle, the plunger forces some of the food out of the top of the can and into my mouth. Now I clip it to my tray. Now, coffee. Also in a tube. First, I cut off the end of the sealed plastic tube. Now, I force the end over the flat hot water nozzle and push against this plunger. Each time I push, I get 2 ounces of water, which is forced out of the tank by a spring-loaded bellows. Oh, I forgot my bread and butter and strawberries. You know, the first day out, I made a mistake and set the can down on the counter. I thought it was down, and then spent the next 15 minutes trying to catch it. So now, I screw the expeller onto the can, and then lock it in my tray. Now, everything's ready but me. Because sanitation is so important here, I have to wash my face and hands with one of these wash and dry napkins. When I'm finished eating, I'll wash the tray and the expelling devices, and of course I'll spray the tubes and cans with iodophor, reseal them, and replace them in their original position. The wash and dry napkin goes in here, and I squirt a little iodophor into the compartment to retard bacteria growth. Thanks to the research and development skills and the ingenuity of Whirlpool Corporation, outer space is almost like home. At least when it comes time to eat. And I'd better start eating my meal right now. The other fellows in the crew are probably getting hungry, waiting their turn. So, thanks for joining me in outer space, in the Whirlpool Space Kitchen. There's nothing like it on Earth.